Agents can do three things. They can access your files, they can access the internet, and then now they can write custom code and execute it. You should really only let an agent do two of those three things. If you can access your files and you can write custom code, you don't want internet access because that's one, it's a vulnerability, right? If you have access to internet and your file system, you should know the full scope of what that agent's capable of doing. Otherwise, malware can get injected or something that can happen. And so that's a lot of what we've been thinking about is like, how do we both enable this because it's clearly the future, but then also, what are these enforcement points that we can start to like protect?
All right, welcome to the Latency podcast in the Chroma studio. Welcome to all the guests here. We're back with our guest host, Vivu. Welcome. Good to have you back. And our friends, Nader and Kyle from Nvidia. Welcome.
Yeah, thanks for having us.
Yeah, thank you.
Actually, I don't even know your titles. I know you're like architect something of Dynamo.
I'm one of the engineering leaders and architects of Dynamo.
And you're director of something, developers.
Developer tech. Yeah.
You're the developers guy at Nvidia.
Open source, agent marketing, Brev, and dev tools and stuff. Kind of in the focus.
And we're kind of recording this ahead of Nvidia GTC, which is coming to town again, taking over town, which we'll all be at. And we'll talk a little bit about your sessions and stuff.
Yeah, we're super excited for it.
One of my favorite memories for Nader, like you always do like marketing stunts, and like while you were Brev, you like had this surfboard that you like went down to GTC with, and like Nvidia apparently liked it so much that they bought you. Like, what was that like?
We our logo was a shaka. We were always just kind of like trying to keep true to who we were. I think, so much of startups, you're like trying to pretend that you're a bigger, more mature company than you are. And it was actually Evan Conrad from SF Compute who was just like, you guys are
previous
like,
guest. Yeah.
Oh,
amazing.
Really?
Yeah,
amazing. Yeah. He was just like, guys, you're two dudes in a room. Why are you pretending that you're not? And so then we were like, okay, let's make the logo a shaka. We brought surfboards to our booth to GTC and the energy was great. Some palm trees too.
They actually poked out over like the walls, so you could see the Brev booth and no one else, just from very far away.
Oh, so you remember it back then?
Yeah, I remember it. Pre-acquisition, I was like, oh, those guys look cool.
Dude, that makes sense because we signed up really last minute, and so we had the last booth. It was all the way in the corner, and so like I was worried that no one was gonna come, so that's why we had like the palm trees. We really came in with the surfboards. We even had one of our investors bring her dog, and then she was just like walking the dog around to try to like bring energy towards our booth.
Yeah, Steph.
But yeah, she's the best.
As a conference organizer, I love that, right? Like, it's like everyone who sponsors a conference comes, does their booth. They're like, we are changing the future of AI or something, some generic bullshit. And like, no, like actually try to stand out, make it fun, right? And people still remember it after 3 years.
Yeah.
Yeah. You know what's so funny? I'll give you this clip if you want to add it in. But my wife was at the time, fiance, she was in medical school and she came to help us because it was like a big moment for us. And so we bought this Cricut. It's like a vinyl printer because like how else are we going to label the surfboard? So we got a surfboard. Luckily was able to purchase that on the company card. We got a Cricut and it was just like fine tuning for enterprises or something like that we put on the surfboard. And it's 1 a.m. the day before we go to GTC. She's helping me put these like vinyl stickers on and she goes, she's like, if you pull this off, you son of a bitch. And so pretty much after the acquisition, I stitched that with the news of the acquisition. I sent it to our family group chat.
Yeah. No. Well, she made a good choice there. Was that like basically the origin story for Launchables? Is that maybe we should explain what Brev is?
I mean, Brev is it's a developer tool that makes it really easy to get a GPU. So we connect a bunch of different GPU sources. So the basics of it is like how quickly can we SSH you into a GPU? And whenever we would talk to users, they wanted a GPU. They wanted an A100. And if you go to like any cloud provisioning page, usually it's like 3 pages of forms, or in the forms somewhere there's a drop down, and in the drop down there's some weird code that to translate to an A100. And I remember just thinking like every time someone says they want an A100, like the piece of text that they're telling me that they want is like stuffed away in the corner. Yeah. And so we were like, what if the biggest piece of text was what the user's asking for? And so when you go to Brev, it's just big GPU chips with the type
with
that you want.
With beautiful animations that you worked on. pre you can now you can just prompt it. But back in the day,
those were
handcrafted artisanal code.
Yeah, I was actually really proud of that because it was I made it in Figma, and then I was like really struggling to figure out how to turn it from like Figma to React. So what it actually is just an SVG, and I have all the styles, and so when you change the chip, whether it's like active or not, it changes the SVG code, and that somehow like renders like looks like it's animating, but we just had the transition slow, but it's just like a JavaScript function to change the like underlying SVG, and that was how I ended up like figuring out how to move it from Figma. But yeah, that's artisan.
Speaking of marketing stunts, though, he actually used those SVGs, or kind of used those SVGs, to make these cards.
Oh yeah,
like a GPU gift card that he handed out everywhere. That was actually my first impression of Natter.
Yeah, I think I still have one of them.
They look great.
Yeah, I have a ton of them still actually in our garage, but just they don't have labels. We should honestly like bring them back. But I found this old printing press here, actually just around the corner on Van Ness, and it's a 3rd generation San Francisco shop. And so I come in, an excited startup founder, trying to and they just have this crazy old machinery, and I'm in awe because the whole building is so physical. Like you're seeing these machines. They have like pedals to like move these saws and whatever. I don't know what this machinery is, but I saw all 3 generations. Like there's like the grandpa, the father, and the son. And the son was like around my age.
Well, it's like a holy trinity.
Yeah. And it was funny because I just took the same SVG and we just like printed it, and it's foil printing. So they make a mold that's like an inverse of like the A100, and then they put the foil on it, and then they press it into the paper. And I remember once we got them, he was like, "Hey, don't forget about us." I guess like early Apple and Cisco's first business cards were all made there, and so he was like, "Yeah, we get like the startup businesses, but then as they mature, they kind of go somewhere else." And so I think we were talking with marketing about like using them.
We should go back and make some cards.
100%.
Yeah, I remember, as a very, very small Brev investor, I was like, why are we spending time doing these like stunts for GPUs? Like, I think like as a, typical like cloud hardware person, you go into AWS, you pick like T5 XXL, whatever, and then it's just like from a list and you look at the specs, like why animate this GPU? And I do think like it just shows the level of care that goes throughout Brev and also Dynamo.
And Nvidia. I think that's what the thing that struck me most when we first came in was like the amount of passion that everyone has. Like I think you talk to Kyle, you talk to like every VP that I've met at Nvidia goes so close to the metal. Like I remember it was almost a year ago, and like my VP asked me, he's like, "Hey, what's Cursor? And like, are you using it? And if so, why?" And I'm just like surprised at this. And he downloaded Cursor and he was asking me to help him like use it. And I thought that was or like just show him what why we were using it. And so the amount of care that I think everyone has, and the passion and appreciation for the moment, right? This is a very unique time. So it's really cool to see everyone really like appreciate that.
Yeah. One thing I wanted to do before we move over to sort of like research topics and the stuff that Kyle's working on is just tell the story of the acquisition, right? Like not many people have been through an acquisition with Nvidia. What's it like? Just anything you'd like to say.
I mean, it's a crazy experience. I think, we were, the thing that was the most exciting for us was our goal was just to make it easier for developers. We wanted to find access to GPUs, make it easier to do that. And then actually your question about launchables. So launchables was just make one-click deploys for any software on top of the GPU. And so what we really liked about NVIDIA was that it felt like we just got a lot more resources to do all of that. I think, NVIDIA's goal is to make things as easy for developers as possible. So there was a really nice like synergy there. I think that, when it comes to like an acquisition, I think the amount that, the soul of the products align, I think is going to speak to the success of the acquisition. Yeah. And so it, in many ways, feels like we're home. This is a really great outcome for us. Like we, I love brev.nvidia.com. Like you should use it.
It's a front page for GPUs.
Yeah.
If you want GPUs, you go there.
And it's like internally is growing very quickly. I don't remember. You said some stats there.
Yeah. It's I wish I had the exact numbers, but like internally, externally, it's been growing really quickly. We've been working with a bunch of partners, with a bunch of different customers and ISVs. If you have a solution that you want someone that runs on a GPU and you want people to use it quickly, we can bundle it up in a launchable and make it a one-click run. If you're doing things and you want just like a sandbox or something to run on, right? Like OpenClaw, huge moment, super exciting. And we'll talk into it more, but internally, people want to run this, and we know we have to be really careful from the security implications. Do we let this run on the corporate network? Security's guidance was, hey, run this on Brev. It's in, it's a VM. It's sitting in the cloud. It's off the corporate network. It's isolated, and so that's been our stance internally and externally about how to even run something like OpenClaw while we figure out how to run these things securely. But
I think there's also like you almost like were the right team at the right time when Nvidia is starting to invest a lot more in developer experience or whatever you call it, UX or I don't know what you call it, like software. Like obviously Nvidia is always investing in software, but like there's like this is like a different audience.
It's a wider developer base. Right.
Yeah, it's funny. It's like it's not.
So like, what is it called internally? What is this that people should be aware that is going on there?
What like developer experience? Or?
It's called just developer experience, or is there like a broader
I think,
strategy here?
Nvidia always wants to make a good developer experience. The thing is, a lot of the technology is just really complicated. Like it's not. It's I think the thing that's been really growing, or the AI is growing, is having a huge moment, not because like, let's say data scientists in 2018 were quiet then and are much louder now. The pie is right. There's a whole bunch of new audiences. My mom's wondering what she's doing. My sister's taught herself how to code. Like the, I actually think just generally AI is a big equalizer, and you're seeing a more like technologically literate society. I guess like everyone's learning how to code. There isn't really an excuse for that, and so building a good UX means that you really understand who your end user is. And when your end user becomes such a wide variety of people, then you have to almost like reinvent the practice, right?
Yeah.
You have to
actually build more developer UX, right? Because there are tiers of developer base that were added. The hackers that are building on top of OpenClaw, right? For example, like have never used GPU. They don't know what CUDA is. They just want to run something, right? You need new UX that is not just, hey, how do you program something in CUDA and run it? And then we built, like when deep learning was getting big, we built Torch but recently the amount of like layers that are added to that developer stack has just exploded because AI has become ubiquitous. Everyone's using it in different ways.
Yeah, it's moving fast in every direction, vertical, horizontal. You
even take it down to hardware, like the DGX Spark. It's basically the same system as just throwing it up on big GPU clusters.
It's a Grace Blackwell.
We saw the preview at the last year's GTC, and that was one of the better performing videos of our NVIDIA coverage so far.
Awesome.
This will beat it.
That was actually fun.
Fingers crossed.
Yeah, even when Grace Blackwell or when DGX Spark was first coming out, getting to be involved in that from the beginning of the developer experience, and it just comes back.
You
were
involved?
Yeah.
Very directly.
Say more.
Yeah, I mean, it was just like I got an email. We just got thrown into the loop, and suddenly. It was actually really funny because I'm still pretty fresh from the acquisition, and I'm getting an email from a bunch of the engineering VPs about like the new hardware GPU chip, or not chip, but just GPU system that we're putting out. And I'm like, okay, cool. Natter's now involved with this for the UX. I'm like, what am I going to do here? So I remember the first meeting, I was just like kind of quiet as I was hearing engineering VPs talk about what this box could be, what it could do, how we should use it. And I remember one of the first ideas that people were ideating was like, the first thing that it was like, I think a quote was like, the first thing someone's going to want to do with this is get two of them and run a Kubernetes cluster on top of them. And I was like, I think I know why I'm here. I was like, the first thing we're doing is easy SSH into the machine. And just kind of like scoping it down of like, once you can do that, like the person who wants to run a Kubernetes cluster onto Sparks has a higher propensity for pain than someone who buys it and wants to run OpenClaw right now, right? If you can make sure that that's as effortless as possible, then the rest becomes easy. So there's a tool called Nvidia Sync. It just makes the SSH connection really simple. So if you think about it, like if you have a Mac or a PC or whatever, if you have a laptop and you buy this GPU and you want to use it, you should be able to use it like it's a GPU in the cloud, right? But there's all this friction of like, how do you actually get into that? That's part of Brev's value proposition is just, there's a CLI that wraps SSH and makes it simple. And so our goal is just get you into that machine really easily. And one thing we just launched at CES, it's still in like early access. We're ironing out some kinks, but it should be ready by GTC. You can register your Spark on Brev. And so now if
like remote managed local
single
hardware.
pane of glass.
Yeah.
Because Brev can already manage other clouds anyway, right?
And you use the Spark on Brev as well, right?
Yeah, exactly. So you set it up at home. You can run the command on it, and then it gets it's essentially it'll appear in your Brev account. And then you can take your laptop to a Starbucks or to a cafe, and you'll continue to use you can continue to use your Spark just like any other cloud node on Brev.
Yeah.
And it's just like a pre-provisioned
cellular data center in your home.
Yeah, exactly.
Yeah.
Tiny little data center.
Tiny
It's
little
the size
data
of your
center.
phone.
Yeah.
One more thing before we move on to Kyle. Just have so many Jensen stories, and I just love mining Jensen stories. My favorite so far is SOL. What is SOL?
SOL is actually, I think, of all the lessons I've learned, that one's definitely my favorite.
It'll always stick with you.
Yeah. When you're a startup, everything's existential, right? Like we've run out of money. We were like on the risk of losing payroll. We've had to contract our team because we ran out of money. And so because of that, you're really always forcing yourself to like understand the root cause of everything. If you get a date, if you get a timeline, you know exactly why that date or timeline is there. You're pushing every boundary, and like you're not just accepting like a no just because. And so as you start to introduce more layers, as you start to become a much larger organization, SOL is essentially like, what is the physics, right? The speed of light moves at a certain speed. So if light's moving something slower, then you know something's in the way. So before trying to like layer reality back in of like, why can't this be delivered at some date? Let's just understand the physics. What is the theoretical limit to like how fast this can go? And then start to tell me why. Because otherwise people will start telling you why something can't be done. But actually, I think any great leader's goal is just to create urgency. There's an
create compelling events, right?
Yeah.
SOL is a term that Nvidia is used to sort of like instigate a compelling event. You say, this is done. How do we get there? What is the minimum, as much as necessary, as little as possible thing that it takes for us to get exactly here? And it helps you just break through a bunch of noise.
Yeah.
Instantly.
One thing I'm unclear about is, can only Jensen use the SOL card? Like,
no.
You know,
Everyone.
like get the bullshit out, because obviously it's Jensen, but like, can someone else be like, no, like
frontline engineers use it.
okay.
I think it's not so much about like get the bullshit out. It's like give me the root understanding, right? Like if you tell me something takes 3 weeks, it's
First
like, well,
principles.
the first principles. It's like what's why is it 3 weeks? What is the actual what's the actual limit of why this is going to take 3 weeks? If let's say you wanted to buy a new computer and someone told you it's going to be here in 5 days, what's the SOL? Well, like the SOL is like I could walk into a Best Buy and pick it up for you, right? So then anything that's like beyond that is that practical? Is that how we're going to, let's say give everyone in the company a laptop? Like obviously not. So then like that's the SOL. And then it's like, okay, well, if we have to get more than 10, suddenly there might be some, right? And so now we can kind of piece the reality back.
So this is the Paul Graham do things that don't scale.
Yeah.
And this is also the what people would now call BHI agency.
Yeah.
Right?
It's actually really interesting because there's a second hardware angle to SOL that like doesn't come up for like all of the org. So SOL is used like culturally at Nvidia for everything.
I'm also mining for like, I think that can be annoying sometimes when like someone keeps going SOL at you, and you're like, guys, like we have to be stable. We have to fucking plan.
Yeah.
Like,
It's an interesting balance.
I encounter that with like actually just with Alec, right? Because we have a new conference, so we need to launch. We have goals of what we want to launch by the conference, and like at the end of the day,
is this GTC or something?
Well, this is like we did it for CES, we did it for GTC DC before that. We're doing it for GTC San Jose. So I mean, like we have a new moment. And we want to launch something, and we want to do so at SOL, and that does mean that there's some level of prioritization that needs to happen, and so it is difficult, right? I think you have to be careful with what you're pushing. Stability is important, and that should be factored into SOL. SOL isn't just like build everything and let it break. That's part of the conversation. So as you're layering in all the details, one of them might be, hey, we could build this, but then it's not going to be stable for XYZ reasons. Yeah. And so that was like one of our conversations for CES was, hey, like we can get this into early access, registering your Spark with Brev, but there are a lot of things that we need to do in order to feel really comfortable from a security perspective, right? There's a lot of networking involved before we deliver that to users. So it's like, okay, let's get this to a point where we can at least let people experiment with it. We had it in a booth. We had it in Jensen's keynote. And then let's go iron out all the networking kinks. And that's not easy. And so that can come later. And so that was the way that we layered that back in. Yeah. But it's not really about like saying like you don't have to do the maintenance or operational work. It's more about saying, it's kind of like highlights how progress is incremental, right? Like what is the minimum thing that we can get to? And then there's SOL for like every component after that, but there's the SOL to get you to the starting line, right? And that's usually how it's asked. On the other side, like SOL came out of like hardware at Nvidia, right? So SOL is like literally if we ran the accelerator or the GPU with like
at basically full speed with like no other constraints, like how fast would be able to make a program go.
Yeah.
Right. So
in training that, like, then you work back to like some percentage of like MFU, for example.
Yeah, that's a great example. So like there's an SOL MFU, and then there's like, what's practically achievable.
Cool. Shall we move on to sort of Kyle's side? Kyle, you're sort of coming more from the data science world. I mean, I always, whenever I meet someone who's done work in tabular stuff, graph neural networks, time series, these are basically, when I go to NeurIPS, I go to ICML, I walk the back halls, there's always like a small group of graph people, small group of tabular people, and like there's no one there. And like, it's very, like, you know what I mean? Like, it's important, interesting work if you care about solving the problems that they solve.
Yeah.
But everyone else is just LLMs all the time.
Yeah. I mean, it's like the black hole, right? Has the event horizon reached this yet in NeurIPS?
But like, those are transformers too. Yeah. And those are also like interesting things. Anyway, I just want to spend a little bit of time on that background before we go into Dynamo proper.
Yeah, sure. I took a different path to Nvidia than Nader. I joined 6 years ago, 7 if you count when I was an intern. So I joined Nvidia like right out of college, and the first thing I jumped into was not what I'd done during internship, which was like, like some stuff for autonomous vehicles, like heavyweight object detection. I jumped into like, something like recommenders. This is popular. And
you did Rexis.
Yeah, Rexis. Well. Yeah. I mean, that was the tabular data at the time, right? You have tables of like, audience qualities and item qualities, and you're trying to figure out like which member of the audience matches which item, or more practically, which item matches which member of the audience. And at the time, really, it was like we were trying to enable recommenders, which had historically been like a little bit of a CPU-based workflow, into something that like ran really well on GPUs. And it's since been done. Like there are a bunch of libraries for Rexis that run on GPUs. The common models like deep learning recommendation model, which came out of Meta, and the wide and deep model, which was used or was released by Google, were very accelerated by GPUs using the fast HBM on the chips, especially to do vector lookups. But, it was very interesting at the time and super, super relevant, because like we were starting to get like this explosion of feeds and things that required recommenders to just actively be on all the time. And sort of transitioned that a little bit towards graph neural networks when I discovered them, because I was like, okay, you can actually use graph neural networks to represent like relationships between people, items, concepts. And that interested me. So I jumped into that at Nvidia and got really involved for like 2-ish years.
Yeah. And something I learned from Brian Cannizzaro is that you can just kind of choose your own path in Nvidia.
Oh my God, yeah.
Which is not a normal big corp thing. Yeah. Like you have a lane, you stay in your lane.
I think probably the reason why I enjoy being in a big company, coming from a startup guy,
the mission is the boss.
It feels like a big game of pickup basketball. Like, if you want to play basketball, you just go up to the court and you're like, hey, we're gonna play this game and we need 3, and you just like find your 3. That's honestly for every new initiative. That's what it feels like.
It also like shows, right? Like Nvidia is just releasing state-of-the-art stuff in every domain. Yeah. Like, okay, you expect foundation models with Nemotron. Voice just randomly, Parakeet. Like top tier Parakeet just comes out. Another one,
the Nvidia voice team has always been producing.
Yeah, there's always just every other domain of paper that comes out, data set that comes out. And it's like, I mean, it also stems back to what Nvidia has to do, right? You have to make chips years before they're actually produced, right? So you need to know, you need to really forecast.
The design process starts like 3 to 5 years before the chip gets to the market.
Yeah, I'm curious more about what that's like, right? So like you have specialist teams. Is it just like, people find an interest, you go deep on whatever, and that kind of feeds back into, okay, we expect predictions. Like the internals at Nvidia must be crazy, right? You must, not even without selling to people, you have your own predictions of where things are going, and they're very based, very grounded, right?
Yeah, it's really interesting. So there's like 2 things I think that Nvidia does which are quite interesting. One is like we really index into passion. There's a big sort of organizational top-down push to like ensure that people are working on the things that they're passionate about. So if someone proposes something that's interesting, many times they can just email someone like way up the chain that they would find this relevant and say like, hey, can I go work on this?
That's actually like, I worked at a big company for a couple of years before starting on my startup journey. And like, it felt very weird if you were to like email out of chain, if that makes sense.
Yeah.
The emails
at Nvidia are like mosh pits.
Huge. And
It's just like 60 people, just whatever, and like there's
Doesn't it get messy? Like reply all.
it's insane. It's insane.
agents help, manage the context now.
but that's actually like I've actually, so this is a weird thing where I used to be like, why would we send emails? We have Slack. I'm the exact opposite. I feel so bad for anyone who's like messaging me on Slack because I'm so unresponsive.
So you're email maxing.
I'm email maxing now.
Email is a different
email
purpose.
is perfect because
we can't work together. I'm stuck.
Email is great because important threads get bumped back up. Right.
Yeah.
And so Slack doesn't do that. So I just have like this casino going off on the right or on the left. And like, I don't know which thread was from where or what, but like the threads get, and then also just like the subject. So you can have like working threads. I think what's difficult is like when you're small, if it's not 40,000 people, I think Slack will work fine. But I don't know what the inflection point is. There is going to be a point where that becomes really messy and you'll actually prefer having email because you can have working threads. You can CC more than 9 people in a thread.
You can fork stuff.
You can fork stuff, which is super nice. And just like, yeah. And so, but that is part of where you can propose a plan. You can also just like start, honestly, momentum is the only authority, right? So like if you can just start to make a little bit of progress and show someone something and then they can try it, that's I think what's been, I think the most effective way to push anything forward. And that's both at NVIDIA and I think just generally.
Yeah.
There's the other concept that like is explored a lot at NVIDIA, which is this idea of a $0 billion business. like market creation is a big thing at NVIDIA. Like,
you want to go and start a $0 billion business?
Jensen says we're completely happy investing in $0 billion markets. We don't care if this creates revenue. It's important for us to know about this market. We think it will be important in the future. It can be $0 billion for a while. I'm probably mangling his words here. But like, I'll give an example. NVIDIA's been working on autonomous driving for a long time.
Like an NVIDIA car?
No,
they've used the Mercedes, right? They're on the HQ, and I think it finally just got licensed out. Now they're starting to be used quite a bit.
Yeah.
But for 10 years, you've been seeing Mercedes with Nvidia logos driving around.
If you're in like the South Bay near Santa Clara, it's actually
from South Bay.
This track. Yeah. So, $0 billion markets are a thing. Like, Jensen.
I mean, okay, look, cars are not a $0 billion market, but yeah, that's a bad example.
I think he's messaging
zero today, but
or even like internally, right? Like it's like an org doesn't have to ruthlessly find revenue very quickly to justify their existence, right? Like a lot of the important research, a lot of the important technology being developed. That's kind of where
research is very ideologically free at NVIDIA.
Yeah,
like they can pursue things that they.
Were you research officially?
I was never in research officially. I was always in engineering.
Yeah.
I'm in an org called Deep Learning Algorithms, which is basically just how do we make things that are relevant to deep learning go fast.
That sounds freaking cool.
And I think a lot of that is underappreciated, right? Like time series. This week, Google put out a new time series paper. Rexus, semantic IDs started applying transformers, LLMs to Rexus. And when you think the scale of companies deploying these, right? Amazon recommendations, Google Web Search, like it's huge scale and you want fast.
Yeah. Yeah, actually, there's a fun moment that brought me like full circle. Like Amazon Ads recently gave a talk where they talked about using Dynamo for generative recommendation, which was like super like weirdly cathartic for me. I'm like, oh my God, I've supplanted what I was working on. Like you're using LLMs now to do what I was doing 5 years ago.
Yeah. Amazing. Let's go right into Dynamo. Maybe introduce it to the top down and
I think at this point, a lot of people are familiar with the term of inference. Like, funnily enough, like I went from, inference being like a really niche topic to being something that's like discussed on like normal people's Twitter feeds.
It's on billboards here now.
Very, very strange. Driving, seeing just an inference ad on 101. Inference at scale is becoming a lot more important. We have these moments like, OpenClaw, where you have these agents that take lots and lots of tokens, but produce, incredible results. There are many different aspects of test time scaling so that, you can use more inference to generate a better result than if you were to use like a short amount of inference. There's reasoning, there's requerying, there's, adding agency to the model, allowing it to call tools and use skills. Dynamo sort of came about at NVIDIA because myself and a couple others were sort of talking about these concepts that like, you have inference engines like VLM, SGLang, TensorTLM, and they have like one single copy. They sort of think about like things as like one single copy, like one replica, right? Like one version of the model. But when you're actually serving things at scale, you can't just scale up that replica because you end up with like performance problems. Like there's a scaling limit to scaling up replicas. So you actually have to scale out, to use maybe some Kubernetes type terminology. We kind of realized that there was like a lot of potential optimization that we could do in scaling out and building systems for data center scale inference. So Dynamo is this data center scale inference engine that sits on top of the frameworks like VLM, SGLang, and TensorGLM, and just makes things go faster because you can leverage the economy of scale, the fact that you have KV cache, which we can define a little bit later, in all of these machines that is like unique, and you want to figure out like the ways to maximize your cache hits, or you want to employ new techniques in inference like disaggregation, which Dynamo, had introduced to the world in March. Not introduced; it was a academic topic beforehand, but we're one of the first frameworks to start supporting it, and we want to like sort of combine all these techniques into sort of a modular framework that allows you to accelerate your inference at scale.
By the way, Kyle and I became friends on my first day at Nvidia, and I always loved because like he always teaches me new things.
Yeah, by the way, this is why I wanted to put two of you together. I was like, yeah, this is going to be good.
It's very different, like we've talked to each other a bunch. Actually, you asked like why can't we scale up?
Yeah. You said model replicas.
Yeah. So scale up means assigning more
heavier.
Yeah, heavier, like making things heavier, adding more GPUs, adding more CPUs. Scale out is just like having a barrier, saying I'm going to duplicate my representation of the model or representation of this microservice or something, and I'm going to like replicate it many times to handle the load. And the reason that you can't scale up past some points is like there are sort of hardware bounds and algorithmic bounds on that type of scaling. So I'll give you a good example that's like very trivial. Let's say you're on an H100. The maximum NVLink domain for H100 for most DGX H100s is 8 GPUs, right? So if you scaled up past that, you're going to have to figure out ways to handle the fact that now for the GPUs to communicate, you have to do it over InfiniBand, which is still very fast, but is not as fast as NVLink.
Is it like one order of magnitude, like hundreds?
It's about an order of magnitude.
Yeah, okay.
So
not terrible.
Yeah, I need to remember the data sheet here. Like I think it's like about 500 gigabytes a second unidirectional for NVLink, and about 50 gigabytes a second unidirectional for InfiniBand. It depends on the generation.
I just want to set this up for people who are not familiar with these kinds of like layers and the transfer speeds.
Also,
and all
maybe
that.
even just going like a few steps back before that. Like most people are very familiar with, you see, you can use on your laptop, whatever these SGLang, VLM, you can just run inference. There's all llama.
You can run it on that laptop.
You can run on laptop. Then you get to, models got pretty big, right? GLM5, they doubled the size. So what do you do when you have to go from, I can get 128 gigs of memory. I can run it on a Spark. Then you have to go multi-GPU. Yeah. Okay, multi-GPU, there's some support there. Now, if I'm a company and I don't have I'm not hiring the best researchers for this, right? But I need to go multi-node, right? I have a lot of servers. Well, okay, now there's efficiency problems, right? You can have multiple 8 H100 nodes, but is that how do you do that efficiently?
Yeah, how do you represent them? How do you choose how to represent the model?
Yeah, exactly.
Right? That's like a hard question everyone asks. Like, how do you size? I want to run GLM5, which just came out, new model. There have been 4 of them in the past week, by the way, a bunch of new models.
You know why, right? DeepSeek.
No comment. Yeah, but GLM5, right? We have this, new model. It's of a large size, and you have to figure out how to both scale up and scale out, right? Because you have to find the right representation that you care about. I mean, everyone does this differently. Let's be very clear. Everyone figures this out in their own path.
I feel like a lot of AI or ML even is like this. I think people think, I was, there was some tweet a few months ago that was like, why hasn't fine tuning as a service taken off? And and
that might be me.
It might have been you. But people want it to be such an easy recipe to follow. But even if you look at an MOE
it's
model,
specific to you.
Yeah.
And the model and the situation.
There's so much tinkering. Like when you see a model that has however many experts in the MOE model, it's like, why that many experts? I don't know. They tried a bunch of things and that one seemed to do better. And I think when it comes to how you're serving inference, you have a bunch of decisions to make, and you can always argue that you can take something and make it more optimal, but I think it's this internal calibration and appetite for continued calibration.
Yeah.
And that doesn't mean people aren't taking a shot at this, Tinker from Thinking Machines, RL as a service.
Yeah, totally.
It also gets even harder when you try to do big model training, right? We're not the best at training MOEs when they're pre-trained. Like we saw this with Llama 3, right? They're trained in such a sparse way that Meta knows there's going to be a bunch of inference done on these, right? They'll open source it, but it's very trained for what Meta infrastructure wants, right? They want to inference it a lot. Now, the question to basically think about is, okay, say you want to serve a chat application, a coding copilot, right? You're doing a layer of RL. You're serving a model for X amount of people. Is it a chat model, a coding model? So Dynamo, back to that.
Yeah, sorry. So we sort of like jumped off of, jumped back in. On that topic, everyone has like their own journey. And I like to think of it as defined by like, what is the model you need? What is the accuracy you need? Actually, I talked to Nader about this earlier. There's 3 axes you care about. What is the quality that you're able to produce? So like, are you accurate enough, or can you complete the task with enough,
Performance.
high enough performance? Yeah. There's cost. Can you serve the model or serve your workflow? Because it's not just the model anymore. It's the workflow. It's the multi-turn with an agent cheaply enough. And then can you serve it fast enough? And we're seeing all 3 of these like play out. Like we saw new models from OpenAI that are faster. You have like these new fast versions of models. You can change the amount of thinking to change the amount of quality, right? Produce more tokens, but at a higher cost and a higher latency. And really, like when you start this journey of like trying to figure out how you want to host a model, you think about 3 things. What is the model I need to serve? How many times do I need to call it? What is the input sequence length? What does the workflow look like on top of it? What is the SLA? What is the latency SLA that I need to achieve? Because there's usually this is usually like a constant. You know the SLA that you need to hit. And then like you try and find the lowest cost version that hits all of these constraints. Usually, you start with those things and you say, you kind of do like a bit of experimentation across some common configurations. You change the tensor parallel size, which is a form of parallelism.
I'd say it goes even deeper. First, you got to think what model.
Yes, of course. It's like a multi-step design process, because as you said, you can choose a smaller model and then do more test time scaling, and it'll equate the quality of a larger model because you're doing the test time scaling or you're adding a harness or something. So yes, it goes way deeper than that. But from the performance perspective, like once you get to the model you need to host, you look at that and you say, hey, I have this model. I need to serve it at this speed. What is the right configuration for that?
Do you guys see the recent, there's a paper I just saw like a few days ago that if you run the same prompt twice, you're getting like double
just try it again.
Yeah, exactly.
And you get a lot.
Yeah.
But the key thing there is you give the context of the failed try, right?
Yeah.
So it takes a shot. And this has been like, basic guidance for quite a while. Just try again. Because, it tried. Just try again. Did you try again?
All advice in life. Just
And I think
try again.
it's a paper from Google, if I'm not mistaken, right?
Yeah.
I think it's like a 7-page little short paper.
Yeah.
The title is very cute, and it's just like, just try again. It has context.
Multi-shot. You just like say like, hey, like, take a little bit more, information. Try and fail.
And that basic concept has gone pretty deep. There's like self-distillation RL, where you do self-distillation, you do RL, and you have past failure, and that gives some signal. So people try it again, not strong enough.
For listeners who listen to here, Vibo actually and we run a second YouTube channel for our paper club where
that's awesome.
we would just cover this self-distillation and all that. That's why he's so up to speed on it.
I'll have to check it out.
Yeah, it's just a good practice. Like everyone needs like a paper club where like you just read papers together, and the social pressure just kind of forces you to just.
There's like a big inference reading group at Nvidia.
I feel so bad every time he put it on our he shared it.
One of your guys is big in that. I forget.
Yeah,
Ishan.
Yes, Ishan. Ishan's on my team. Actually, funny. There's a employee transfer between us. Ishan worked for Nader at Brev, and now he's on my team.
He was our head of AI, and then once we got in,
because I'm always looking for like, okay, can I start another podcast that only does that thing? Yeah. And Ishan was like, I was trying to like nudge Ishan into like, is there something here? I mean, I don't think there's new inference techniques every day, so it's like
you would actually be surprised. The amount of blog posts you see, and if
there was a period where it was like Medusa, Hydra, Eagle, like
now we have new forms of decode. We have new forms of speculative decoding. Or new.
What are you excited about?
It's exciting when you guys put out something like Nemotron, because I remember the paper on this Nemotron 3. The amount of like post training, the amount of tokens that the GPU rich can just train on, and it was a hybrid state space model, right?
Yeah, it's co-designed for the hardware.
Yeah, co-designed for the hardware. And one of the things was always, the state space models don't scale as well when you do a conversion or whatever, the performance. And you guys are like, no, just keep training. And Nematron chose a lot of that too.
There's
Also, something cool about Nematron, it was released in layers, if you will, very similar to Dynamo. It's essentially it was released disaggregated. The pre-training, post-training data sets are released. The recipes on how to do it are released. The model itself is released,
fully
so you
open
can just
model.
benefit from us churning on the GPUs. But there are companies like ServiceNow took the data set and they trained their own model, and we were super excited and celebrated
Zoom,
that work.
Zoom,
Yeah.
the frontier model lab.
Zoom is
AGI.
I think also just to add, like, a lot of models don't put out base models, and if there's that, why is fine tuning not taken off? You can do your own
That's a good
post training,
question.
but
Yeah, that's true.
you guys put out base model. I think you put out everything.
I believe.
I don't know about
so.
base. Base
Put
can
out
be
base.
base can be
Request before.
cancelable.
Base can be cancelable.
Yeah.
Safety training.
Did we get a full picture of Dynamo? I don't know if
I
we.
feel like
we
what I'd love is you mentioned the 3 axes. Like, break it down of, like, what's pre-fill, decode, and like what are the
Yeah,
optimizations that we can get with Dynamo.
Yeah, that's a great point. So to summarize on that 3-axis problem, right? There are 3 things that determine whether or not something can be done with inference: cost, quality, latency. Right? Dynamo is supposed to be there to provide you like the runtime that allows you to pull levers to mix it up and move around the Pareto frontier or the Pareto surface that determines, is this actually possible with inference and AI today?
Gives you the knobs.
Yeah, exactly. It gives you the knobs. And one thing that like we use a lot in contemporary inference and is starting to like pick up from in general knowledge is this concept of disaggregation. So historically, models would be hosted with a single inference engine, and that inference engine would sort of ping pong between 2 phases. There's prefill, where you're reading the sequence, generating KV cache, which is basically just a set of vectors that represent the sequence, and then using that KV cache to generate new tokens, which is called decode. And some brilliant researchers across multiple different papers essentially made the realization that if you separate these 2 phases, you actually gain some benefits. Those benefits are basically you don't have to worry about step synchronous scheduling. So the way that an inference engine works is you do one step, and then you finish it, and then you start scheduling the next step. It's not like fully asynchronous. And the problem with that is you would have essentially prefill and decode are actually very different in terms of both their resource requirements and sometimes their runtime. So you would have like prefill that would like block decode steps because you'd still be prefilling and you couldn't schedule because the step has to end. So you remove that scheduling issue, and then you also allow yourself to like split the work into 2 different types of pools. So prefill typically, and this changes as model architecture changes. Prefill is right now compute bound most of the time. If the sequence is sufficiently long, it's compute bound. On the decode side, because you're doing a full pass over all of the weights and the entire sequence every time you do a decode step, and you don't have the quadratic computation of KV cache, it's usually memory bound because you're retrieving a linear amount of memory and you're doing a linear amount of compute, as opposed to prefill where you retrieve a linear amount of memory and then use a quadratic.
It's funny. Someone, Exo Labs did a really cool demo where for the DGX Spark, which has a lot more compute, you can do the compute hungry prefill on a DGX Spark and then do the decode on a Mac. And so
That's faster.
yeah.
So you can do
And
you can do machine stratification.
Yeah.
And like with our future generations of hardware, we actually announced like with Rubin this new accelerator that is prefill specific. It's called Rubin CPX. So
I have a question. When you do the scale out, is scaling out easier with Dynamo because when you need a new node, you can dedicate it to either the prefill or decode?
yeah, so Dynamo actually has like a Kubernetes component in it called Grove that allows you to do this like crazy scaling specialization. It has like this it's a representation that I don't want to go too deep into Kubernetes here, but there was a previous way that you would like launch multi-node work. It's called leader worker set. It's in the Kubernetes standard. And leader worker set is great. It served a lot of people super well for a long period of time. But one of the things that it struggles with is representing a set of cases where you have a multi-node replica that has a pair, right? Prefill and decode, or it's not paired, but it has like a second stage that has a ratio that changes over time. And prefill and decode are like 2 different things. As your workload changes, right, the amount of prefill you'll need to do may change. The amount of decode that you'll need to do might change, right? Like let's say you start getting like insanely long queries, right? That probably means that your prefill scales like harder because you're hitting these this quadratic scaling growth.
Yeah. And for listeners, like prefill will be long input, decode will be long output, for example, right?
Yeah. So like decode scale. I mean, decode is funny because the amount of tokens that you produce scales with the output length, but the amount of work that you do per step scales with the amount of tokens in the context.
Yes.
So it both scales with the input and the output.
That's true.
But on the prefill decode side, like if suddenly like the amount of work you're doing on the decode side stays about the same or like scales a little bit, and then the prefill side like jumps up a lot, you actually don't want that ratio to be the same. You want it to change over time. So Dynamo has a set of components that tell you how to scale. It tells you how many prefill workers and decoded workers it thinks you should have, and also provides a scheduling API for Kubernetes that allows you to actually represent and affect this scheduling on your actual hardware, on your compute infrastructure.
Not gonna lie, I feel a little embarrassed for being proud of my SVG function earlier.
No,
It was really cute. I like
it's all engineering. It's all engineering.
That's where I'm technical.
One thing I'm kind of just curious about you see at a systems level everything going on here, and we're scaling it up in distributed systems. I think one thing that's like kind of the moment right now is people are asking, is there any SOL sort of upper bounds in terms of like just call it context length for want of a better word, but you can break it down however you like.
Yeah.
I just think like, well, yeah, I mean, like clearly you can engage in hybrid architectures and throw in some state space models in there all you want, but it still looks very attention heavy.
Yes. Long context is attention heavy. I mean, we have these hybrid models.
And most models like cap out at 1 million contexts, and that's it. Like for the last 2 years has been it.
Yeah. The model hardware context co-design thing that we're seeing these days is actually super interesting. It's like my passion, like my secret side passion. We see models like Kimi or GPT-OSS. I'm going to use these because I know specific things about these models. So Kimi 2 comes out, right? And it's an interesting model. It's like a DeepSeek style architecture. It is MLA. It's basically DeepSeek scaled like a little bit differently. And obviously trained differently as well. But they talked about, why they made the design choices. For context, Kimi has more experts, but fewer attention heads. And I believe a slightly smaller attention dimension, but I need to check that. It doesn't matter. But they discussed this actually at length in a blog post on Jihu, which is like
Reddit. Yeah.
In
Chinese
China.
Reddit. Yeah.
So it's actually an incredible blog post. Like all the MLSys people in that I've seen that on GPU are like very brilliant. But they talk about like the creators of Kimi K2 actually like talked about it on there in the blog post. And they say, we actually did an experiment, right? Attention scales with the number of heads. Obviously, like if you have 64 heads versus 32 heads, you do half the work of attention. You still scale quadratically, but you do half the work. And they made a very specific like sort of barter in their system, in their architecture. They basically said, hey, what if we gave it more experts? So we're going to use more memory capacity, but we keep the amount of activated experts the same. We increase the experts sparsity, so we have fewer experts. The ratio of experts activated to number of experts is smaller. And we decrease the number of attention heads.
And kind of for context, what we had been seeing was you make models sparser instead. So no one was really touching heads. You're just having...
Well, they implicitly made it sparser.
Yeah, for Kimi, they did.
Yes.
They also made it sparser. But basically what we were seeing was people were at the level of, okay, there's a sparsity ratio. You want more total parameters, less active, and that's sparsity. But what you see from papers like, the labs like Moonshot, DeepSeek, they go to the level of, okay, outside of just number of experts, you can also change how many attention heads and less attention layers, more attention layers. Yes. So, and that's all basically coming back to just tied together is like hardware model co-design, which is
hardware model context co-design.
Yeah.
Right. Like if you were training a model that was like really, really short context, or like really is good at super short context tasks, you may like design it in a way such that like you don't care about attention scaling because it hasn't hit that like the turning point where like the quadratic curve takes over.
How do you consider attention or context as a separate part of the co-design? Like I would imagine hardware, or just how I would have thought of it is like hardware model co-design would be hardware model context co-design.
Because the harness and the context that is produced by the harness is a part of the model once it's trained in.
like, even though towards the end you'll do long context, you're not changing architecture through
I see.
training.
Yeah,
I mean, you can try.
You're saying everyone's training the harness into the model?
I would say to some degree.
Or there's co-design.
I know
for
there's
the
a small
harness.
amount, but I feel like not
No.
everyone has like gone full send on this
I
stuff yet.
think it's important to internalize the harness that you think the model will be running into the model.
Yeah.
Interesting. Okay.
And like
that's one.
Bash is like the universal harness.
Yeah,
Right,
Like,
like-
I'll give an example here, right? I mean, or just like a it's easy proof, right? If you can train against a harness and you're using that harness for everything, wouldn't you just train with the harness to ensure that you get the best possible quality out of?
Well, I can provide a counter argument,
Yeah,
which is
sure.
what you want to provide a generally useful model for other people to plug into their harnesses.
Yeah,
right?
but
So if you
harnesses can be open source, right?
yes,
We
I mean
see
that's
stuff like-
effectively what's happening with Codex.
yeah.
But like you may want like a different search tool, and then you may have to name it differently. Or
I don't know how much people have pushed on this, but can you train a model? Would it be have people compared training a model for the harness versus like post training for?
I think it's the
harness?
same thing.
It's the same
It's
thing.
just
Okay.
extra post training.
I see.
And so I mean, Cognition does this, Cursor does this, where you just have to like if your tool is slightly different, either force your tool to be like the tool that they train for, or like undo their training for their tool and then
that's funny.
retrain.
Yeah.
It's really annoying and like
I would hope that eventually we hit like a certain level of generality with respect to harness
correct. Like
training.
this,
So you
this
could
is not
introduce new tools.
This is not AGI. Like it's just like it's really stupid. Like learn my tool, bitch. Like I don't know if I can say that, but like I think what my point kind of is that there's like I look at slopes of the scaling laws and like this slope is not working, man. We're at 1 million token context. Okay, maybe next year 2 million. We're not going to 100 trillion. You know, like this
There's so many interesting
this
ways you can get
doesn't
there,
work.
though.
This doesn't work.
What's kind of funny is whenever I feel like we always want to see a trend that we can predict, but every time something's come, it's been like a leapfrog. So I imagine, I don't know how we go from 1 to 2, but I imagine what's likely to happen is we break through that from some new.
Yeah, there's an interesting formalization of this. There's an essay. It's a pretty interesting essay by Leopold Aschenbrenner called Situational Awareness.
Okay, yes.
He introduces a concept in
familiar with
situational
that, yes.
awareness called an unhobbler, right? So he Leopold in this essay details, hey, I want to get, I want to get to this point in intelligence, and I think that it is 4 orders of magnitude worth of like compute and data and training away. And he says, oh yeah, I think data centers can scale up by about this much. I think that you can do, scale up the data and some other things by this much. But one of the things that like makes the rest of that order of magnitude growth possible is these unhobblers, like these scientific discoveries that are discovered during, model architecture search or training that really, really, really impact how you are able to scale. Like a good example of this might be that like we see like a lot of models that are, and this is probably a very tiny unhobbler, but is important for the performance perspective. We see a lot of models that are like trained with multi-token prediction natively during pre-training. Mm-hmm. And, per DeepSeek in their paper, they say, hey, this actually helped us ensure more stable convergence. But they're like unhobblers that are like that. And then there are like rather large unhobblers, right? Like architecturally, a lot of our models, like we have different types of attention, right? And one of the problems with attention is like you have a lot of KV, but people have found like different forms of attention, like group query attention and like MLA in DeepSeek, multi-head latent attention, that like decrease the burden that KV has on the model, which allows you to grow like longer in context.
Yeah, and that was very drastic for DeepSeek.
Yeah,
This was like,
for context, like the total, I think the total context length of DeepSeek is 128,000 tokens, or it might be 256,000 with rope extension. That entire context, I think it's 128,000, fits into 8 gigabytes. And previously, context, like I think the Llama 405B context of a similar size was like 40 or 80 gigabytes in the same precision.
yeah.
So like those unhobblers like really decrease the stuff of that size. And I wouldn't be surprised if we do see the ability to like break through to like 10 million, 20 million, 100 million context through an unhobbler showing up.
I see.
And it's just science.
So more deep learning algorithms is what
Yeah,
I'm
more
hearing.
deep learning algorithms. I could
He's playing
actually
pickup and he has room for 2.
I could actually give you an example of a theory, not a theory here, but something theoretically.
An
that could
hobbler
happen.
that you're excited about it?
Well, an unhobbler that I haven't seen, so it could be a tar pit and it could not work. But I would be really excited to see a model that does prefill and decode differently. So a model that does prefill like locally, like document-wise prefill, like it does it in chunks, and then you do decode globally across like the entire sequence. Because logically to me, it doesn't seem like you would necessarily need to have KV be associative between documents that have like no mutual association. But that like places a lot of burden on prefill to on decode and pure attention within the decode phase to like make those connections, since the KV is like static at that point. And you see other techniques that are interesting like this too. But if you're able to do that, like, if prefill becomes local and decode is still global, you solve that prefill quadratic scaling problem because you have a bunch of like small chunks that you prefill independently.
Okay. All right. Well, let's wait and see. But I think it'll be pretty exciting.
Fingers crossed.
Yeah, fingers crossed. Yeah.
I'm excited for like prefill decode on separate hardware. So like
Yeah.
Grok acquisition, right? Can we decode on the Grok? Can we get super fast?
I don't think I'm allowed to comment on this.
Mark is gonna shoot arrows at us.
He's got a blow dart.
Yeah, he's in the side of the room, just like go to sleep.
Yeah.
Yeah, but I'm super excited to see the team come in, and like I've gotten the pleasure of working with some of the Grok people coming in. So I know
Sunny, we've had him at the same
that's
conference
awesome.
that you were at.
Yeah.
And I think you guys are going to be doing some sessions at GTC. I don't know if you want. This is a good place to plug them.
Yeah. So I can't speak to any LPU related sessions at GTC. I have no idea about that.
Oh no,
No, yours.
you.
On the Grok side, yeah, I use the associative NVIDIA U. On the NVIDIA Dynamo side, we're giving it. There are a large number of sessions. For those that aren't aware, you can actually search all of these sessions for GTC online. Just go to the GTC website. I don't know what the URL is, but go there.
Google it, yeah.
And you can just look up Dynamo and you'll get all the sessions. There are about 20. There are a couple that are hosted by the Dynamo team. There are a couple that are hosted by people that use Dynamo that want to show off the results they've been able to get. But there are two that I'm really excited about. One is just the general Dynamo tutorial. And this is I'm going out with Harry, who's our lead product manager for Dynamo. And we're sort of talking about like how to use Dynamo to get better performance and also like where we see Dynamo going in the future. And then there's another session that I'm doing with one of our agents teams at NVIDIA to talk about sort of the future of agents in production inference. So we're talking about there's like this new horizon with respect to agents because we have these harnesses that actually impart structure upon calls. Like if you compared like, the past and the present with respect to like how LM calls work, like in the early days when they were chatbots, like every call was like very different. There was basically no structure. You could assume that like people, if it was conversational, there might be like some implicit structure because you have, a multi-turn conversation. But agents, you have this harness that like abides by rules, right? So it imparts direct structure onto the context. And you see this, there was an interesting Twitter post about how Claude Code like structures its context so that you get as many cache hits as possible. And I think it was by one of the PMs for Claude Code, and he wrote about it. And that type of structure that the harness can impart actually like goes hand in hand with the inference co-design. So I'm doing a talk. I don't know the session name or the session number, but I'm doing a talk. You can look me up by name on the GTC website on how we accelerate agents and where we see specific optimizations for agents going in Dynamo and in inference in general.
Yeah, I think there's only one PM for Cloud Code, and it's Cat Wu. The rest, there's Devrel, there's Boris.
Maybe it was Devrel.
Yeah,
Right,
exactly.
right.
I mean, let's go into agents. I think this is like the last part of the discussion we planned.
How have we not talked about agents?
Also with you guys
we scheduled it.
being-
I was like, okay, like let's have like cohesive sections or
I mean, there's the big news, right? Nvidia is a huge like deployment of Codex.
Yeah,
in terms
NVIDIA
of-
uses everything. I mean, we use this cursor and we use this.
But that's a
Codex.
pretty big deployment, right? Like that's tens of thousands of people.
Totally. Yeah, we're
I'm
super
curious what it's
excited.
like.
Yeah, I mean, it goes back to the mosh pit of emails we kind of mentioned earlier, or just how fluid the org feels. So when there's new technology, people will just email it out, and everyone will try it. And if it's making people's lives easier, it'll spread like wildfire.
A lot of times Jensen will get it and will be like, let's make this work across the company. Let's make this work right now.
Honestly, if I was a startup, I feel like a cool hack. If you have something that's going to save an NVIDIA's time, they'll spread it to a couple, and the same thing, right? It'll just spread like wildfire. Like
Careful before your email blows up from startups. By the way.
well, you gotta know the person, right? But no, So I mean, I love using Codex. It's been a ton of fun. I've been using it personally. Been using it at work. It's been Yeah, I don't know. It's been great to see the rollout. Something really funny on a day that we got Codex and Claude Code access. I found this person, his name's Carlos at the company. He wrote an Outlook CLI.
Oh yeah.
And just a CLI for email. And this was,
I've been using that.
yeah, maybe like 4 or 5 weeks ago. And the site, so once I got like Codex access, I installed the CLI. It had a skill, and I just asked it to go through all of my emails, which it's very messy. So if I don't respond to your email, I'm really sorry. But I asked it to give me a summary, highlight any escalations that I should look at, put any thread that it thinks I should respond to in a folder, and then archive everything. And it did. So if I missed your email, it's because it didn't get picked.
So I should put a prompt injection in my emails to What you should do is just FaceTime, which is my SLA is highest on FaceTime.
But it was magic. And so I sent it in a big email thread to like 500 people. A bunch of folks tried it out. I started like FaceTiming whoever I could at the company to get them set up with this.
Yeah. That specific example, you guys deal with like some pretty sensitive emails.
Yeah.
Is there a security review with this? Because like one guy made it for himself, but like it's not meant for all of it.
Security team at Nvidia is incredible. Like shout out to them. They're trying to.
We have an amazing security team because they're progressive and they know that this is really important technology and we have to bring it in. If you think about like, if you work at a big company, your laptop's usually very locked down. If you can only access certain things, NVIDIA engineers have like, those restrictions aren't there. So you're expected to understand the risks when you try things out. And so very quickly, made sure to chime in security on what we were doing. There's actually a lot that we've been thinking about, especially with OpenClaw, right? Like there's, agents can do 3 things. Yeah, I mean, agents can do 3 things. They can access your files, they can access the internet, and then now they can write custom code and execute it. And you should really only let an agent do 2 of those 3 things. If you can access your files and you can write custom code, you don't want internet access because that's one vulnerability, right? If you have access to internet and your file system, you should know the full scope of what that agent's capable of doing. Otherwise, malware can get injected or something that can happen. And so that's a lot of what we've been thinking about is like, how do we both enable this because it's clearly the future, but then also, what are these enforcement points that we can start to like protect?
And is there any directive of like, hey, we have a company account or company agreement with OpenAI, we use OpenAI models here, or like choose whatever?
No. So I would never put any company data in a model that's not either that we don't even.
It has some security.
Yeah.
Like how
that goes. Obviously you could run your own models. You have Nitron and we
have an internal cluster. So of course,
Running a Dynamo.
Yeah.
I think we're Dynamo's first customer.
Actually, there's a funny story about like how I got the experience that informed what we needed for Dynamo. At one point, there's a website called build.nvidia.com, and also for us, inference.nvidia.com, that allows people to try models. It gives an API service. You can call the model with like a REST API, and you get a response. I ran the model side for that, and it was at one point the largest inference deployment, and still may actually be the largest inference deployment in NVIDIA. I've since like handed that off to some people and they're doing wonderful.
Well, this is an extremely underknown or less known resource. Build.nvidia.com, you can get any of these open source models and it's rate limited, but it's free. So it's perfect for hackers to just
and the SLA on getting models, day 0 models up is like a day.
Yeah.
Like they're incredibly good at like figuring out the right way to host the model to get it up there as soon as it comes out.
You ran this?
Yeah, I ran it a long time ago. It was originally called NVIDIA AI Playground. Then it was called AI Foundation.
Yeah.
And then it was called build.nvidia.com. Okay. And I ran the model side of it. So there was a large multi-organizational team. I ran which models should we host? How should we host them? And like, what's the proportion of them? And then of course there was like an SRE team that like made sure that things ran well and scaled the models as well. But I ran like, model, how do we get the model to silicon? And then, which also worked with our product team to determine like which models were important a very long time ago.
Yeah. There's also like a middle ground in between there. This is like for the hacker, try anything. There's the Brev console, then there's Dynamo. There was also NIMS, right?
Yeah.
I remember it had its little moment like a year or 2 ago. Is it still?
Yeah, no, NIM is inference module. Well, I think it left it for something.
It's no longer an acronym.
Yeah,
it's just
a NIM. But NIM is how enterprises can take our any of this technology and run it with support and all of that. And so that includes Dynamo. That includes all of our other optimizations that are packaged up for enterprise.
Yep.
Yeah. Anyway, so you got a bunch of experience like running the sort of internal inference gateway playgrounds.
Yeah, I also built helped build Nvidia's first internal like VS Code thing. We called it MB Code.
It's like the extension.
Yeah, it was a VS Code.
First like the fork VS Code.
Look, we joked absolutely not. We joked a while back. We should have a fork VS Code hackathon where you.
That's for it's just the best for VS Code.
We were doing a
How do you make $1 billion?
someone from VS Code was there, and he was like somewhat down to get involved, and I was like,
Oh, you should do that. That's all.
Then the cool thing became for Chrome hackathon.
Chrome.
And now IDs are not cool.
I was talking to Joseph from RoboFlow and
Your partner in crime.
we were talking about how with the new Alpha Mayo model, so Nvidia just released an open source the Mercedes cars that you saw drug
Which is crazy.
Yeah.
You open source a autonomous driving model.
So so we were thinking like, could we hackathon a driverless car? Like I have my old car, let's just try it.
We'll take it to like Treasure Island in the middle of the day. Just see, let it roam.
Yeah, like how many cameras do we need, right? Like 1, 2, 3, 4, I don't know, maybe 5, 6. But I think we're gonna try. You just do it with us. We can even have a race. It's like the first person to automate the driving.
Let me over a weekend. We do have an autonomy track at World's Fair. Waymo was there. Like Nvidia did send people. But it was for Groot, not because he didn't have the driving thing yet. That's cool.
I think Comma also has a version of this. Comma, they have open source driving. They've done a fun hackathon on
Is it he and I had talked because I really want is a Tesla with Tesla level self driving.
Yeah.
But as a smart car, like a 2-seater. That's basically a wheelchair with a roof.
I don't think they make them into, but the thing is, the demand has been there.
They don't make no. They're like this for like 5 years.
Yeah,
Really? Yeah.
they were different manufacturers.
I feel like it's one of those things where we'll see someone buy the brand and it'll be revived.
I would buy it.
Like I'm probably that would go. Someone hears this, go buy.
Yeah. That's crazy. No, because like
Mercedes.
because they're like I think about 10% are Mercedes.
And they're saying you're used to make them.
Yeah.
I don't know. I feel like they own the brand, and you have.
That's
Your dream might come true.
Okay, we're time to get you asking on fire. Every time I try to park in San Francisco, I have to buy a smart car because like 20% of the parking lots in San Francisco only fit smart cars.
Yeah.
So
Really?
that's what I mean. That's like small.
You've been late here trying to promote.
This comes from someone that like basically does not drive.
That's where the Vespa was a life hack.
Yeah, exactly.
Yeah, you know what happened to the Vespa? I used to have this yellow Vespa. I left it outside the hacker house when we moved out. It was always there, and then like a month ago, it's not there anymore. I've been meaning to do. I don't know.
You could have let lights. It's actually been here. Like a TV.
You forgot about it.
Yeah,
And left.
Yeah. No, it's probably a hazard. And speaking of hackathons, I also wanted to give a big shout out to the world's shortest hackathon.
let's go.
You did twice.
We're gonna a handful of times. Yeah, there's gonna be one at GTC.
Oh, we're doing another one?
Pretty much, we have a bunch of challenges that we haven't released, and you get to bring your agent to come and attempt to go through those challenges.
Yeah, it's like the 0-minute hackathon idea. Was you just bring your? I probably seen it a long time ago. You just bring your agent, and then you press the go button. You're not allowed to code. It's just the agent doing hackathon.
It's a good hidden eval, right? Yeah, you make a gyro and you make.
Like I feel like this is something I would love to see from Cognition or someone else. Be like, come, bring your agent.
Like drop it in.
Because you don't know you like to provide. Will it be operate a browser, order a pizza? Will it just see like that snake game,
And you don't know what the task is.
Yeah, you don't know what the task is. Like, or just like you don't even know what the judging categories are, and then you give it the judging categories. Like, try and win as much as possible.
It's great till it turns into like, so let's build something on Dynamo.
It's a great business.
Okay, funny story actually. We have a couple of people at Nvidia. We've been working with security to like bring agents really close to compute. So we now have like stuff where you can like tell Dynamo, like go run some experience with Dynamo, like on, X cluster and just like try it right now. Like queue up. Once you get queued, like, send this request load. And we've actually been able to like, just like, like one shot problems. Like we used to have this problem where like, with Dynamo, you have to like find the right configurations. And we, sort of do it automatically for some parts of it, but you have to have like a good initial configuration that you want to use. And we've just had like an agent just completely one shot that. It gets the compute, it like runs a couple experiments. It's like, this is the best. These are part of the Pareto frontier. Go run this. And then we just like give that to people and it's like faster than anything that they have.
Agent UX and agent marketing are super important. There's stuff that we've been thinking a lot about. Alec is like redoing the entire Brev CLI so that you can fetch all the different compute types that are available. I don't know, it's gonna be really soon, but then you can just browse what GPUs are available and then provision one, SSH to it right there, and you can pipe all the commands. But I think it goes back to like the Alec CLI. Like if you coding agents are it's kind of funny. I feel like coding agents have been so much more effective than general purpose agents, and I think a large part of that is it just has access to the terminal, like you said. And that means it has access to everything that you've installed into your terminal. It can run, so it would write code and it can compile the code. And if there are errors, it can fix it. It can run your suite of tests because that's all just in your terminal. And so that, that's for the idea, or what got me really excited about the Outlook CLI. We're now just churning through building CLIs for the entire business suite. Slack, building Slack, also Workday CLI, SAP Go.
I've also done that for myself.
Really?
Yeah.
We're gonna open source all of this. And like, all they're CLIs for the business applications. We would love for someone to run with this and like build like, I don't know, like Open CLI Foundation or something. Yeah, NVIDIA would love to support anyone that's doing this.
Like every dev tool should really have good CLI support at this point. Like at one point it was, you want your docs to be accessible by an LLM, right? You want LLM good doc. No, everything needs some CLI tool.
Yeah, it's kind of funny, right? Like computing began with a terminal with a shell, but we said that it's not empathetic to humans, so we built these nice user interfaces. And then now we have LLMs navigating our user interfaces, and ironically, we're not empathetic to the machine anymore.
Yeah.
just give the LLM access to the shell.
One thing that slightly makes me uncomfortable is like, why do we have to build CLIs? Why can't we just expose APIs? Like,
I have an interesting answer to this. So there are a couple of reasons. Like there's like, portability is like one issue. Like, like sometimes APIs are not like discoverable or like reachable by some, types of things. Like there's some element of locality, right? Like the CLI is like literally you interfacing with your like local system, which is a little bit different. You could still do it by API, but like there's this highlighting of like, what is the difference between like a CLI and an MCP, right? Like they kind of occupy the same purposes, and you call them, it does something on the system, and that's done. I think that in pre-training, there's just an enormous amount of command line data. Yeah.
Mm-hmm.
Yeah. Like even let's ignore RL. Like you're doing no harness push training. Just the amount of like CLI versus API documentation for just like navigating this world of the CLI in your file system through that is just enormous.
Yeah.
Right.
I think there's a couple of things too. Like if let's say we want to, so one, I think your intuition is right. The CLI is just wrapping the API, right? So functionally, right? Yeah. And I think it's nice because one, you're being very specific and pedantic even of what, and that's really good because you're describing the problem space. So you know what the I don't want to call it like what the space for vulnerability. You know what network calls you're making. It's not arbitrary, and that's not decided on the fly. That's like pre-decided, which is important from a security perspective. But then if you were to write a bunch of API requests, you would probably do that. I don't know, would the model like use Python to do so? I kind of like that everything like a CLI is just bash because it's ubiquitous. Like it's just there, and you don't have to make sure that there's certain environment variables that are set up. Like if your Python version is different than my Python version, we're using the same model to go do the same thing. Is it going to write like different code? It probably would. And so it's kind of
nice to go work, right? With a human as well.
No, I think just like making those decisions happen ahead of time versus,
one last thing on this sort of agent, I guess, maybe co-location or whatever you call it. One pattern I'm tracking for this year, I always try to think about what's the theme of this year going to be. Last year, definitely coding agents. This year is definitely coding agents breaking out of containment into broader real world. Like it definitely has to.
Here, rent a human.
Yeah. Yeah.
I'm on.
Are you really?
I'm like $5,000. I'll do anything. Really? I think so.
I need my bowels from Costco.
But I think the best part is only the agent can book me,
Yeah.
It's very usually like, it's just like another labor marketplace.
Mechanical Turk was this.
So this, I have a weird story with why I did it. So back to your example of just giving agent access to compute, right?
Yeah.
You guys are GPU rich at Nvidia. Yeah. I hooked up.
He's not shy about it.
I have a 24/7 agent running. I hooked up to RunPod. It doesn't shut down instances, and I'm like, I've tried prompting it. I've given it instructions, shut down when you're done. It's like, I have to keep it warm. I'll need it soon. And it's horrible on time estimates too, because like they realize it's like, yeah, I'll need it in 45 minutes. 45 minutes, I'll shut it down. 45 minutes of human time is actually 3 minutes of agent time. So it's like, I'm booting it up. I'm waiting. I'll just leave it on all night. And Modo's good at shutting down after some inactivity. I had it on my local server, like a little dual GPU thing. It just stays on. I have a little space heater at home now. But careful. So basically, you know, they don't care about the concept of money. Just burn it. I need it. It's useful.
And another thing where DGX Spark will be really nice. Like I think I'm looking at it as it's super useful for agents because you buy it once, you plug it in, and it can rip.
I'm gonna make an Nvidia ad here. Okay. The Blackwell like RTX 6000 cards Pro are only like, I think it's $8,000, slightly cheaper. Yeah, well, it's much cheaper than the data center cards. Yeah, and it's got 96 gigabytes of VRAM. So if you and your crew want to go like run a local agent for you in the home, I feel like it's got a significant amount of VRAM. I've thought about purchasing this and running in my basement, except my neighbors would hate me.
It's just a single like 2-3 slot GPU. It's
it's a PCIe. It's a PCIe GPU. You can go buy that. I mean, the big difference against like the RTX like gaming GPUs is I mean, obviously it's like Blackwell, like it's a pro GPU and it has a lot of VRAM, which means you can run pretty large models on it.
You can stack 4 of them for the max Q in a system. That's a beast.
It's beefy. You can run what is that, 96?
You can run anything, 96.
You can run a DeepSeek.
But also they are slow. They're not, I mean, performance of speed will be somewhat slower compared to API. Like,
oh yeah, that's true. So again, the big learning, economy of scale allows you to do things that allow you to get both speed and throughput. Like you can run, I'll give you an example. There's an optimization called wide EP. I'm not going to go into it fully, but like it featured heavily in Inference Max for DeepSeek. And there's a great set of stories from Nvidia and from SemiAnalysis about like why YEP is important. But for like MOE models, it's like basically essential. And you run it like a level of parallelism, the level of scale up parallelism used for it is like 32. So it goes beyond that 8 barrier, and it like really, really, really is important to have that MVL72, GB200 NVLink to serve at scale. And like, it's like, I don't remember the cost improvement. I think against Hopper, right? Like against Hopper with this MVL72 system, you're getting like 35 times cheaper per token for like a lot of the curve. Yeah. Which is crazy.
Yeah.
And normalized per GPU, obviously, because part of the GPU's cost or the code, the GPU is part of the cost.
One thing I'm exploring is the sort of this year is also the year of the sub-agent, where you have the main agent, but then that also kicks off tools which are in themselves agents that have limited agents. And sort of
low context,
locally, whatever, right? Yeah. Different prompts. So for example, one thing that Cognition does is before you kick off a search, they do is like a fast context model where you kick off 8 parallel agents to search across the code base. And all that is better than indexing a lot of the times, not all the times. And you should still index for some things. But like the idea that agents should be able to command sub-agents and probably run them like maybe close to inference as well. I don't know if that's like architecturally possible or even
we're thinking about that for Dynamo. That's like our big theme for the year,
because like if you can design that into your stuff, then a lot more people will use it. Right now it's like just kind of theoretical because you do pay a lot of like back and forth coordination costs.
I think it'll net speed up though, right? Like even at a basic level, speculative decoding, you're running a small model, you're running 2 instances, but it's net
that is one example. Yes.
Yeah, but this is like a little bit like different with like agents.
Yeah, this is not spectacular.
Yes. I think there's like a summarization of that trend that I like to do, or I like to say to my team. It's like, this is the year. So there are 2 things. This is the year system as model, right? Where like instead of having like a single model be a thing, you have a system of models and components that are working together to like emulate the black box model. So when you make an API call to something that's like a multi-agent in the background, it still looks like an API call to a model. You're still getting back to
right, but under the hood.
Yeah, under the hood, it's like a billion different models. And that's a lot of complexity, right? With Dynamo and with other libraries in Nvidia, we're looking to help manage that complexity.
Yeah, it's funny. We actually, for CES, we just released a model router. So for DGX Spark, where you can have a local model that's running on the Spark and then also a foundational model. And then the model router decides when to send queries to which one. So it's no longer this like either or. It's use the best of everything that's available to you. You have a good post-trained model that's running on.
This relates to also the Brev functionality of being able to manage the Spark.
That'd be cool.
Oh yeah,
I did do that thing. Feature requested. Yeah, there we go.
I actually like a question like I'd like to like extend and flip over. How much longer do you guys think like agents are going to be running? Because that's one thing I've been throwing around. Like, what happens when?
I mean, always on.
It even affects the like back to the pre-fail decode, right? Like Codex is, I'd say, compared to Cloud Code, it's much longer at tasks. Like
Yeah.
that thing will like to run 6, 7, 8 hours. I'll run it overnight.
Yeah.
And I'll go back and I have like a little crappy logging software I use. And there's just times where it wants to like, I'm going to go deep on research and it'll eat up 80,000 tokens, go on another.
Yeah.
Just eat through tokens. And that's part of it. Like at the end, it does hit a long task. And I think you only see that expand, right?
There's insatiable demand for tokens, and every improvement that comes kind of just makes our demand even higher. It's kind of funny, right? Like if you have like a teammate and you ask them to do a task and they're like, should I save some effort and not think too hard about this task? I'm like, fuck no.
I mean, my favorite was like, you can have 4 shots, right? Yeah. Like the original Codex before the app, why do 1 call? Like give it 4 attempts, just use all the tokens like that, right?
Try more.
Direct objective. Try again, try more.
It's like the meta index, right? Is the thing that tracks like how long models are able to run. I expect that we'll just see like log linear, if not log super linear growth. We will see before the end of the year an agent that is capable of running for longer than 24 hours with like self-consistency the entire time.
I would also poke at different domains having different desires, right? Like at a consumer level, I'm getting slightly frustrated at 20 minutes per basic query. Sure, you can optimize, 6, 8 hour. I don't see myself shooting off many 1-week agents, right? Someone doing like, okay, GPU kernel research or medical or biological, like, in those domains, sure, shoot off a lot that take a lot of up. So like, I think it will be somewhat domain specific because you also really need to train that in, right?
You know what's funny? What if I was doing your taxes, right? Like that's taxes.
Yeah, it's like a month. Yeah, okay.
Yeah, exactly. Get it right.
I wonder if like a maybe supposed to successor to like speculative decoding is like your agent figuring out what you might be prompting it the next day at night and like prefetching.
Yeah, you can already do that. Yeah,
Really?
Branch prediction.
Oh, well, no, that's too low level, but yes. Sorry. Yeah. One question I got to get is, so like, we actually did record a part with the beta folks, was that right here. Their chart is the human equivalent work, hours of work, rather than how long the agents themselves are being autonomous. And there's a huge difference, right? Like human work 5 hours, agent work 30 minutes. Like it's actually 30 minutes, not 5 hours, right? Like so, like that chart that you see is them estimating what the human equivalent replacement is. I think actually Anthropic released a more recent chart that showed Cloud Code autonomy from their production traffic numbers, and that was 20 to 45 minutes. That's roughly where we are. So yeah, that's the sort of realistic thing. I mean, I do think like there's experimental setups where you can just like sort of Ralph Williams like just prompt it to keep going when it stops, and obviously that can go arbitrarily long.
I feel like from my experience around, I guess 20 to 40 minutes seems right for when I'm using like Codex or Cloud Code. But then like what I always try to just like, if I want to spin up like there's a net new project, I'll often start with Replit, and like it'll run for, I believe, Anchor. Yeah. Like spin up like their new like from the V3 agent, like it'll spin up a web browser and like click around and discover new bugs and just keep churning. So I think like my longest was like over an hour that I had been churning.
I think before we see super long running, I think there's going to be a bit of an efficiency hit. So sure, you can take an hour and go down paths, but you also want to be more efficient. You want to be smarter in your reasoning, right? So I think that'll actually go down before we go back up. Like you don't want to scale non-optimized systems just for the heck of it. As much as I love saying use all the tokens, they are expensive. Like going from dense to reasoning models, that's an added cost, right? You're paying for a lot of tokens, and it doesn't make sense to just scale stuff that's not optimized. So there's always that little balance.
Yeah.
But, I think you'll see both sides of it.
Yeah. So 2023 was super exciting. I think if you were in SF, you were like, okay, I know this is going to be a huge world-changing moment, but it seemed like, no one had known yet. And maybe even before. Was it 2022 maybe?
Yeah. I would say, like Rune had this tweet where like everyone was in SF from like 2021 to 2023. Yeah. Like understood what it was like to be like early.
Totally. 2021. That's when I made my first OpenAI account. It was crazy. And I remember it was so funny because at the time, SF had not been doing well. So pretty much what it felt like was the concentration of founders in the city had risen because where my neighbors were used to doing a bunch of stuff, those people had all left. So the only people that were still in the city were people that really wanted to build. It was cheap tech. It was also way cheaper. I feel really bad at anyone who is trying to get rent now. But there was Cello they had a huge office.
So blockchain. Like took over the old Casper building.
Yeah, they had the showroom and they had the what I think was like the back warehouse. It was a huge office, and
It's right across from OpenAI and Neuralink.
Yeah, it was in the original arena.
I named the arena because of it.
Yeah. And so it was really exciting because like RoboFlow, I think I forgot there were
Mintlify.
Mintlify, Brev was there, you guys were there. I remember that was actually, it was there that you bought the AI.engineer domain.
Yeah, I didn't know what I was going to do in AI. I just wanted to do something.
But it was kind of it was a really fun moment where we were kind of all in this solo space, and I don't know, it was a really cool community, especially being so early.
Yeah.
And so
then you got me early cruise access.
oh yeah.
And so there was a golden period of time that both cruise and Waymos were just free.
Yeah, always.
If you had it, I mean, they're so back. Celo's opened again.
So Nature Zooks is doing Zooks and Robotaxi. Yeah. So totally. Yeah.
But yeah, and so it's actually really cool that you guys have this studio so close to Celo.
Yeah.
This rock climbing gym right around the corner. It was like, so you guys, oh yeah. So yeah, it's an awesome block.
Cool. Yeah. Just and a little bit of San Francisco trip, but I do think like one thing I try to do with the podcast is like bring like what it's like to be in San Francisco to the rest of the world, and also just like maybe give El Tepo Taqueria.
Yeah, my favorite tacos in the city, and
yeah, steak and shrimp. I know it's very good.
Yeah, and I guess what it's like to be in San Francisco, I think, is just everyone seems to be super supportive. Sometimes I feel like the city believes in you more than you do. And even, I don't know if you remember, but I remember posting my first blog post, and I had met you on Twitter, and you gave me like an hour of your time super randomly, and you kind of coached me through writing content for developers. And I was trying really hard not to come off salesy or plug myself, and so I kind of stripped all personality out of the blog post.
Yeah.
And you brought that out. You're like, people don't. It's okay to talk about what you're doing. Like, you don't have to be weird about it. And I remember just that. I think that really helped me kind of figure out what our voice is and not shy away from it. And so, always really grateful for you.
Hey, you inject your voice into like everything. It's actually a huge advantage to be like very genuine about what you care about.
Yeah. Yeah. Like, imagine like some random person DMs you and like it's like, can you give me feedback on this blog post? And it's like pretty boring, and you're like, fine, like, you know, he looks interesting, I'll just do a Zoom call. And then you meet this guy, right? He's so energetic. Just be right there. But like, I think people are trained to write a certain way in school, and yeah, they never
Totally.
see there's like a broader world.
A lot to unlearn.
Writing is thinking, and like everyone thinks differently. So like you might as well just like
Yeah.
write your way.
Cool. Well, thank you for indulging with us. Really broad breaking discussion, but I love like you guys are like sort of like the sort of young faces on NVIDIA with so much energy, but like also a lot of technical depth. And I think people learn a lot for this session. So thank you.
This was awesome. Thank you guys. And thank you for everything that you've done. And the talk. Yeah, and the podcast, all the above.
And see you at GTC.
Yeah, we're looking forward to it.
Yeah.
Cool.
It's awesome. Thank you guys. Thank you.